Yes, hi, I'm Kristen Sterling, and along with Doris Blazing, I'm a consultant at RMCG, and Hort Innovation have engaged us to coordinate the R&D projects for the potato industry, and specifically the pest and disease R&D projects. So really that centres around trying to make sure that the outcomes from these projects are communicated out to you, industry members and growers, and that you're aware of what's going on, and providing a level of coordination to the projects as well. So today I'm just going to give, as Doris mentioned, a very brief overview of the projects, and I'm going to put my contact details up at the end. And very happy for anyone to give me a call or email if you want to know more about the projects and what's going on, and or me or Doris. And I'm also going to talk a little bit about some of the resources that we've developed for on soil-borne disease management. So as Josh mentioned, if it's a wet year, that might be something you might want to look out for, and I, again, happy to send that out to anyone who wants a copy if you haven't already got them. So the Pest and Disease R&D program, there's 6 individual projects which are looking at the big ones, powdery scab and pink rot, in terms of soil-borne diseases, but also there's a project looking at tomato, potato psyllid, and how that management of that is coordinated. There's also a project looking at integrated pest management of potato insect pests, biosecurity and diagnostics. And as you might be able to guess, unfortunately COVID-19 has impacted on the delivery of a number of these projects, and I'll talk a little bit more about that as I go through. So Predictor PT, your number one opportunity to understand what you might be planting into and what your risk factors might be in terms of soil-borne diseases. So this project is led by Michael Retke at Sardi. This particular phase of the service started in 2017, but obviously Predictor PT has been around for quite a while, and I'm sure you all know of Michael and the service, and it's due to conclude, this particular phase is due to conclude in 2020, but not the service itself, that will be ongoing. So obviously Predictor PT can test your soil for a number of soil-borne diseases and nematodes, but there have been some new tests added within this particular part of the program, things like for testing for silver scurf, pink rot and verticillium wilt, which might talk about a little bit later on. And it's not only soil that can get tested, it can also be roots and stem, and also peel. So a key focus for this particular phase of the project has been about getting more people accredited to use the Predictor PT service, and it's quite a simple one-day workshop that Michael has been running, so that you can understand the correct way to sample for soil and the peel tests, and also how to analyse the results that come out of that testing. Unfortunately, that has been a bit impacted by COVID because it's normally run face-to-face. But another outcome from this project will be the upgrading of the training manual for that accreditation. So there's 2 projects looking at powdery scab. The first one was run in New Zealand by Richard Falloon, and that concluded in June this year. And really it was looking about that in New Zealand they have some soils which are naturally suppressive to powdery scab or Spongospora, and so they wanted to understand what is it about these soils that suppresses powdery scab, and if we can find out what it is it possible to manage or manipulate other soils which aren't naturally suppressive and try and stop that disease from occurring. Unfortunately, there weren't really any consistent trends or responses to treatment, and so it's been difficult to develop any sort of practical outcomes for industry, but it has been an important step in understanding the biology of these soils and some aspects of disease suppression. There was an interesting response when manganese was added to soils that are naturally low in manganese, and that did have an impact in terms of suppressing powdery scab to a degree. The other project that's looking at powdery scab is led by Callum Wilson down in Tasmania. That started last year, and this is really looking at how powdery scab or Spongospora attacks roots, the potato roots. And ideally, so they're looking at where does that attachment occur, and is it possible to stop that attachment from occurring so that Spongospora can't get into the roots. And then they're also looking at screening a number of the publicly available cultivars for their level of resistance to powdery scab. So initial work has started on that. They've identified that region of the roots where attack occurs, and they've also started screening some of the cultivars for their resistance to powdery scab. Another project which has only just recently started, also down in Tassie, this one led by Robert Tegg, is looking at pink rot. And really the project is going to try and understand what impact soil pH has on pink rot. What does the addition of acidifying fertilisers do to pink rot, and the nutritional status of soil and plants? What sort of impact does that have on pink rot, with the view to developing some guidelines for pink rot management. And this work will involve pot trials, but also survey of a number of farms in Tassie, as that seems to be where pink rot is really having a big impact on production at the moment. Plant Health Australia are responsible for the development of the biosecurity plan for the potato industry. So that's involved looking at what are the high priority pests for the potato industry, and each year they update that listing in collaboration with the whole biosecurity review panel. Unfortunately, they haven't been able to do that this year because it's done face to face. So they haven't been able to update it for 2020. As part of the project, they also developed a biosecurity manual for growers, which was sent out to a whole range of stakeholders in the potato industry. So hopefully you received that. But if you didn't, you can get a copy online at the Farm Biosecurity website. So there's also a project coordinating Australia's response to TPP. That's led by Alan Nankervell at Ausveg. Look, that whole project has actually been suspended due to COVID, because a lot of Alan's work involved face-to-face meetings. So that's been suspended and will hopefully start up again soon. Really the only remaining steps for that project was to organise a seed potato risk workshop and then communicate the outcomes of that workshop to the Plant Health Committee and update the relevant management plans. So hopefully that will start again soon once some of the COVID restrictions have been released. And then the last project is one led by IPM Technologies, which is Paul Horn and Jessica Page, based in Victoria. And this project has also been quite heavily impacted by COVID, because obviously a lot of Paul and Jessie's work is done face-to-face with growers. So they still have been providing remote backup to growers and advisors that they've previously worked with. And they've also done a few Zoom workshops. But obviously dissecting a caterpillar is a little bit difficult to do over Zoom. So, you know, they have been a bit impacted as to what they can and can't do. And it was planned to do quite a number of demonstration trials up in Queensland and New South Wales, but they've been postponed. Paul and Jessie still have been busy, though. They have put together a pocket guidebook, which identifies, it's basically a little guide for the beneficial species and pests in potato crops. This was done separate to the project, so there is a cost involved. But if you would like a copy of that little guide, you can get in touch with Paul and Jessie at IPM Technologies and they will send that to you. So that's the projects. We've also developed a couple of resources, and we've talked to growers and various people to try and figure out what was the soil-borne diseases causing the most problems, and pink rot and powdery scab came up as two of the big ones. So we've done just a quick fact sheet guide on managing pink rot in potatoes, and also powdery scab as well. So it basically just outlines what it is, what it looks like, what are some of the things that contribute to it occurring, and then what are some of the management practices you might want to think about to help manage those expression of those diseases. So I've sent those out electronically. Hopefully you might have got a copy. It's also on the AusVeg website and also on the Soil Wealth ICP website, which Donna will talk about in a minute. If you want a copy, get in touch with me, I can send it out. We've also done one on blackleg, which I haven't sent out yet, but which I'll do in the next couple of weeks, and I'll send that to Josh. So he will hopefully be able to distribute that for me. And once again, we'll put it up on the AusVeg and Soil Wealth ICP websites. And I also just thought I'd let you know, we've just done a big scan of what's happening in terms of R&D for pest and disease in potato crops internationally. So we're just finishing that off at the moment. I'll also send that through to Josh when we've finished that. And yeah, so you can get me at Kristen S at RMCG, or Doris B for Doris. And yeah, we're only too happy to provide further information if you want it. And that's me, Doris.
Yeah, thanks, Kristen. Just one comment to the powdery scab work. You might have picked up that all the testing is done with public varieties. So there might not be innovator included in the testing, which is a real pity. But because I asked Callum about that, but the answer was there's so many PBR varieties that they can't work with them all. So anyway, just comment. Are there any questions from anybody? Okay, all happy. Okay, thanks, Kristen. That was a good overview. So there's actually quite a bit going on. So it's sometimes up to the individuals to actually grab the information. The fact sheets are all not very long and very practical. It's not a scientific treatise, so have a look at them. Okay, we go to Donna, Soil Wealth.
Okay, thanks, Doris. I'll just share my screen with the PowerPoint.
Also, if anybody has questions later, as Kristen said, you know, we only at the end of a phone, so don't be scared to call us.
Okay, so as Doris said, I'll give a very brief overview of the Soil Wealth and Integrated Crop Protection Project. It's a project that started about 5 years ago working with other vegetables, and then last year in 2019 the potato industry also joined. So all of the resources and activities are available for potato growers and other people in the industry, and we're also developing some potato specific resources as well. But there's three main things I wanted to cover today. One is a brief description of the project. Secondly is I'll show you some examples of the resources that are available so you know what's there, what you can access. And thirdly is really a question to get feedback from you guys about what you think might be useful moving forward, because we're currently planning the last 2 years of the project. So how the project works is we take new information on anything to do with soil management or crop protection, and we work basically in the extension and also development area, so not so much in research. We're not working on blue sky research on things that are not tested or tried, but we're taking technologies and adapting them on farms in different situations and looking at the economic benefits of those, for example. The demo sites are an important part of the project, so we've got a series of demo sites right around the country in different vegetable production areas, and they cover things like precision ag using variable rate technologies, or using cover crops, or for example using soil amendments. And it really depends on what the focus is in that region and what the farmer in that region wants to trial on farm. And then We often run farm walks on those demo sites, but we also run other events like masterclasses. Some of you might have attended the soil-borne disease masterclasses or the crop nutrition masterclasses, as well as online events like webinars and the recordings of those are available afterwards. So we also develop a whole range of resources, and I'll show you some of those in a minute, and they range from fact sheets through to webinar recordings and also best practice guides. And we've got a network called a partnership network, and that's a network of people who work with the project, and they might be suppliers, machinery suppliers or input suppliers or researchers, and we work together with them to deliver training and events. So if anyone's interested in that partnership network, you can get in touch with us. But how it all kind of comes together, I guess, the glue that holds the whole project together is the communications and the online resources. So there's a monthly bulletin, an email bulletin that we send out to a big database. If you're not receiving that and would like to get that newsletter, just contact us. We can send out the information after the webinar, I think. And there's also all the resources are available on the Soil Wealth and ICP website. So some examples of some of the things that are potato specific. Actually, I just probably worth mentioning a lot of the resources on the website, even though they might have been before potatoes joined, they're still relevant for potatoes. So, you know, the soil, for example, doesn't care whether there's a potato or a carrot or a bean growing in the soil. The principles of soil health is the same. So there's a whole range of resources that are relevant for potatoes. And we've also got some that are specifically for potatoes, including a recent series of webinars on salinity in potatoes. So there were 4 of them: monitoring for improved management, knowing your salts, managing hydrophobic soils, and also using organic soil amendments for managing salinity. Some other examples, and similar to what Kristen was talking about, we've got a range of disease fact sheets and podcasts, for example, on pink rot, powdery scab, soft rot. And I've got a couple of screenshots there of the pink rot fact sheet, which all of the fact sheets include some practical tips, so how you can manage or control the issues. But in the example of this one for pink rot, we've got some of the weed hosts there as well. There's a biological products database, and what I might do is I'll just jump onto our website and show you what that looks like. So if I just share a different screen. Okay, so hopefully you can see the Soil Wealth website there now. So if I go to the search button at the top here and type in it should come up with the biologicals database.
No, actually, you had crop in there, Donna. You have to call it biological products.
Biological products database.
That might do it.
Thank you. Okay, so there's 2 different databases. One is sorted by trade name and one is by product type. But if I just go to the first example, and you can see here, it gives you a list of, oh gosh, we've probably got hundreds of products in there, and it lets you know whether it's registered, the main ingredients, what it's been used for example, whether it's a growth stimulant or what else have we got here in examples, crop nutrition. And then it's got the analysis as well as where you can find additional information. So we found that that's been really popular, that database. And if I go back to the PowerPoint. But you can also search in that website for potato or any other kind of topic, and it'll give you a list of the resources that are available. Still on the topic of biological products, there was a webinar recently, and that's called At the Cutting Edge and Advancements in Biopesticides. So that recording is available on the website as well, if people are interested in that. So a few other examples. With the demo sites, we've got a potato-specific site in Cowra, and that's focusing on irrigation. And in the past, we've had a site in Tasmania working with the Soil First group, and that was focusing on cover crops. And going forward, we're looking at potentially some other potato demo sites. We might look at things like phosphorus, for example. So there's the website. It's www.soilwealth.com.au. And I think Josh might have sent out a copy of this summary of resources. So that lists all of the resources that are available on the website for the project. And the final thing I wanted to mention is that we're currently planning what we do in the last 2 years of the project. So if anybody online has ideas about what you need and what would be useful for potato growers and the types of things that would have an impact on farm or in the factory, then we'd be keen to hear from you and see if it can fit in with our project plan, any information in particular that you'd like to see. So that was a quick overview of some of the resources.
Thanks, Donna. And just to your last point, the project on pink rot came actually out of a conversation we had between a grower and Frank McKay, Simplot, who really felt something practical should be done. And anyway, so that project was born out of conversation with a few people. So it's possible to get things going, even though it took a couple of months, but we still got it going. So don't be shy with your ideas, please. Any questions?
So Doris, people can also put any comments in the chat box too, if they like.
Yes, yes, on the bottom, or email us. There's the chat function. When you go down to the screen, it pops up. But I haven't had any chats from anybody yet. So we keep going with our guest presenter from the US, David Hernandez. David, would you like to introduce yourself? You probably can do that better than I do.
Yes, I will introduce myself, and then I will allow Mr. Mick to set a presentation, because he will have a few things to say before me. My name is David Hernandez. I am a soil fertility specialist, and I look young, but I'm not that young. I've been in the business for more than 25 years, and my passion is soil health and sustainability. Since I was very young, I was inspired by looking for a different type of agriculture. I didn't want to allow the next generations to have a dirty planet. And finally, my dream is coming reality. I think this is not any longer a dream. I think this is a direction that we're going. I have a PhD in soil fertility nutrient management, and I currently work for Acta Group. It's a company owned by Nutrien, and they develop technologies for plant and soil health. And today we will discuss a little bit about this, and we will focus a little bit more in phosphorus. But I think with that, I will allow Mick to take over.
Thanks, David. Thanks everyone for the time and the opportunity to present. So my name is Mick Darling, co-presenting with David Hernandez. I'm with the Nutrien Ag Solutions business based out of Melbourne, and originally from a farm down in Gippsland, and predominantly over the last sort of 15 plus years of my working career have been involved in various aspects of the fertiliser industry. And the last 10 years or so with what was Landmark, now known as Nutrien, it's been really heartening to see the amount of investment that Nutrien is putting in from a global standpoint in improving fertiliser use efficiency, not only in Australia, but globally. And so I think the theme of today is really quite, it's quite on point, and we're grateful for the opportunity to present what we're working on from a phosphorus use efficiency point of view, but also touch on some of the biological and biostimulant aspects of work that we're in as well. So I'm going to attempt to share my screen here, and let me know once you can see that. So hopefully you can all see that. So in the next...
We can't yet.
All good. Okay. So we've been given about 25 minutes, and in that time, we want to highlight, I suppose, some of the common challenges that we are facing in the potato industry. We want to walk through some of the solutions that we're working on from a nutrient standpoint, and specifically touch on a couple of the technologies that we think will provide a real benefit in this space to not only improve fertiliser use efficiency, but hopefully that is going to carry on through improved soil fertility, soil health, and
I can't see your screen for some reason.
No, I can't either.
Okay, it might not share.
It's not share yet.
Bear with me. Shit. How about now?
Looks better. Yes, got it.
So, okay, sorry about that. So really, we want to just touch on, I suppose, a couple of these key technologies that we're investing in as a business, and a couple of those key technologies are around reacted carbon and biochemistry, which is the byproduct of a living system. So if we touch on some common factors, I suppose, that are impacting our potato crop yields on farm, soil type obviously is a big one. There's going to be variability across the states that we're farming in, and this is going to be around the physical variability in our soils, the chemical makeup of our soils, and microbial properties within those soils as well. Obviously, for those of you that are from the southeast of SA and the Mallee area, we're typically dealing with fairly high pH soils in alkaline conditions. Calcium can be quite a factor there. Conversely, down in parts of Tasmania and parts of Vic, we're predominantly dealing with neutral to slightly acidic soils. So iron and aluminium can be predominant factors there, particularly around phosphorus use efficiency. Phosphorus buffering index is another thing that quite often we take into account with regard to how well our soils are cycling phosphorus and the propensity for them to tie up phosphorus from what's applied. So organic carbon is also going to vary. So potentially lower in parts of the Mallee where we're farming potatoes, and might be slightly higher in areas of Vic and Tassie. So salinity levels is another big one. Obviously, irrigation water with high salinity or dissolved salts, particularly chloride, sodium chloride in particular, is a real problem for us. And limiting uptake it will limit the uptake of nitrogen, potassium and calcium in particular. So with regard to in-season temperatures as well, particularly at planting, we're dealing with fairly low soil temps, and that in effect is going to reduce the microbial activity earlier on in the season. So the more we can do to increase the availability of that applied nutrient early on in the crop, as those soil temperatures warm, that's going to do a hell of a lot for our establishment of the crop going forward. Heat stress is another big one during the growing season, and for that reason it's really critical to manage K and keep an eye on K levels, for instance, with your SAP testing to make sure that K is adequate, because it's very important from a stomata control point of view with the plant, and making sure that plant can transpire and manage its moisture levels and mitigate against some of that heat stress. And just finally there, fertiliser types used are really going to determine the nutrient availability during the season, and this is what David and I want to go into in a little bit more detail shortly. Just before we do that, this, I suppose, just sets the scene on, I guess, the theme of the presentation. Australia is, I suppose, one of the last developed countries where on-farm is not regulated, and us in the potato industry are all, I suppose, guilty, for want of a better word, or it's just the nature of play that there are some very large amounts of basal fertiliser applied per hectare. And some of the work we've been doing in Tasmania recently, you know, we're applying about 260 odd units of phosphorus, for example, up front at planting, and, you know, an average crop coming off down there might be only removing 60 to 70 units of P. So, you know, there's a lot of phosphorus that's going out in some of those soils, and we're really, I suppose, there's a responsibility from a sustainability point of view that we think outside the square and invest in areas that improve the fertiliser use efficiency on farm. And the big push from a customer point of view around sustainability farming practices are really driving our industry towards better ways of doing things on farm. One of the main drivers on the back of that is a lot of the funding, R&D, the increased adoption and interest of some of these alternative farming methods on farm when it comes to the likes of biologicals, biostimulants, advanced fertiliser chemistry that really serve to improve nutrient uptake by the plant and reduce losses to the environment. But, you know, as we saw on that database that got presented a moment ago, you know, it's a very crowded space and it can be pretty daunting. And, you know, there's a lot of businesses and companies that come to us as Nutrien and want the ability to sell through our network. We put a lot of scrutiny around those companies, as do we put a lot of scrutiny around the R&D that go into some of our own products that we're working on and technologies in those. So Nutrien's investing in R&D. We're working with third parties to bring technologies to you, our customers, and we're dealing with both external collaborators in terms of generating independent replicated trial work, and we're also working directly with you, our growers, with regard to commercial scale demos on farm. But I suppose ultimately this all boils down to how can we do more with less? So as I said, there's a lot of companies, I suppose, you know, driving up driveways and offering the next best thing. And as I said, one of the heartening things I see from a Nutrien point of view is the amount of investment the company's putting into vetting a lot of these technologies and making sure that the science is sound before we go and commercialise any of these products. So over the last 8 years or so, the company's put in about 650 US million, which is about 900 million Australian dollars in capital invested into either acquiring or working very closely with third-party collaborators. And in 2019, Actigrow was acquired by Nutrien, and that's the company David Hernandez has spent a lot of time working with, which is specifically around linodite-based technologies and reacted carbon in those technologies as well. But essentially all those companies are doing very different things and working on different things, and they bring a lot of expertise and quite a diverse range of expertise to the table with regard to a sole purpose, and that is improving fertiliser use efficiency. So a couple of the technologies that we're working on at the moment, specifically with potatoes, is a product called Structure that we'll have a good look at this coming season. And I'll let David go into some more detail about it, but just quickly, it's based on reacted carbon technology, or RTC. It's derived from linodite, and it's essentially a nutrient source that's reacted under heat and pressure to provide, in this case, a nitrogen phosphorus product with a bit of zinc and 8% reacted carbon, which is applied upfront at planting, but it can also be applied in crop. Phosphorus obviously is not very mobile from where it's placed, but the reacted carbon is really assisting us with mobility and availability. and in crop. So I'll let David go into a little bit more detail on that shortly. The other product that we're doing quite a bit of work with is a product called Foundation LM, and it's been worked with for quite some time in the US. It's the byproduct of a bacterial system. We make it locally in Dandenong, just out of Melbourne, at our manufacturing facility there. And there's no live biology in the final product. And I suppose that's the key differentiator around it being a biochemical versus a biological. So it's not bugs in a drum, for want of a better term. It's concentrated biochemistry, and it's the byproduct of that living microbial system that we manufacture the product in. The final product is a very stable and consistent formula. So it's not batch fermentation, which a lot of the biological products are on the market, and they do vary quite a lot in terms of their consistency. So the product gets applied at planting, and from a key benefits point of view, it's really working to stimulate the existing microbial population that is in that rhizosphere, particularly if you're putting it out at planting. It's really working to serve to increase that soil nutrient mineralisation that's taking place directly in the root zone, and increasing the efficiency of our applied fertiliser. So if you think about what our bacterial system's doing naturally in our soil profile, this is kind of shortcutting that, or at least eliciting a response on those on that bacterial system to improve what they're already doing. This slide just demonstrates a little bit around the diversity of the product, and there's a lot of products on the market that claim to be just one single bacillus strain, for example, and you're really reliant on a particularly if it's just a single strain product, to colonise the root zone and actually produce a byproduct before you actually get a benefit out of it. Quite often, a lot of those biological products that are applied on farm can be overtaken by the native populations of biology that are in that soil profile, and naturally they see it as a bit of a threat, and there's a potential that they may not be able to colonise it for you to be able to get a benefit from the application of that product. The big difference around putting the biochemistry out versus a live biological is the diversity of the organic compounds that you're putting out there. And again, in general terms, these are enzymes, proteins, organic acids that are produced by our biological system. But you can see here every peak in this graph, which is a mass spectrograph that was done on the final product. And you can just see that the diversity in this product, and of the 20 known amino acids, for example, that have been produced or are known worldwide, there's been 15 identified in Foundation. If you go through some of the other key points that have been identified in the product, 11 organic acids, some volatile organic compounds, there's cytophores in here, and cytophores are the byproduct of microbes, but specifically their sole purpose is to solubilize iron. So in situations where we've got high iron tie-up, we see this as a real strength in helping solubilize some of that iron in our profile. So again, a very diverse final product, and that diversity is key to the performance. This is some work in terms of biochemistry, and the ability to influence that biology in the soil can be very visual in the paddock. So this was a photo from a couple of years ago, just outside Ballarat, where the left was treated with biochemistry versus the right that was untreated. The crop was planted the same day, but you can see there just the ability to be able to provide those signalling compounds to the root zone, and to stimulate that microbial process that's taking place was really able to benefit that crop in this particular season. And this is really going to vary by paddock. So sometimes it can be as visual as what you see on the screen there. This was some work that was done a couple of years ago in Manjum up in WA. So this was putting out foundation at 10 litres a hectare in furrow planting. And on the left, this was sort of two trials in one. So the first was a Mac Russet trial, and that 10 litres of foundation at planting was able to give us significant increase in terms of tonnes per hectare, which was quite promising versus grower standard. The Atlantic potato trial, in this case, we had grower standard where foundation wasn't applied. We had foundation applied at 10 litres in furrow, which gave an increase from 65 tonne to the hectare to 68 tonne to the hectare. We also had a second application on one of the treatments of another 10 litres of foundation, and this was applied via the pivot in crop, and again, just helped mineralise some of that nutrient that was already in the profile and increase that mineralisation that was taking place in crop. So more of that applied nutrition that was in that soil was able to make its way into the plant, and it carried through from a yield point of view. So that's just a bit of a quick overview of foundation. David, I'll hand over to you to run through structure if you wouldn't mind, and we can perhaps take some of the questions then.
Sure. I just forgot to tell you guys that for me I am in the US, so for me it's like 9:20 p.m. and I'm still awake. I mean, I'm a late to go to bed guy, and I have an accent too. I'm originally from Venezuela, but I've been in the US for over 25 years. So I apologize if you had this combination of accents that you would see here, but let's move forward to the next slide. So Actagro is not a new company. Actagro is a technology company. They have global presence, and it has been around with the creation of technology since 1982. And it was just recently in 2019 when Nutrien Global decided to purchase this company and utilize the experience for their global platform to introduce these kind of solution-based technologies to growers across the world. Next, please. The company was based originally in California, and the origins of the company came from traditional fulvic and humic acid technology. But early in the 80s, in 1980s, that technology was failing in California. Even though it was a lot of enthusiasm for the technology, it was very inconsistent. And growers sometimes got results and sometimes don't get the same results, or got something quite different. Even though good, they never could consistently obtain the same type of results. And by that time, actually, someone who was interested in the topic, decided to investigate. It was a PhD in chemistry, organic chemistry, and he came up with some ideas to process leonardite instead of producing fulvic and humic acid, to do processes in a different way, trying to mimic what petroleum or people who use crude oil petroleum will change the way to process the petroleum and obtain tires or Tupperware or gasoline or even nylon. They apply similar processes in a way to obtain differentiation in technology. And within this technology, they observe, and they was just trial and error, they observed they obtained some benefit in the molecules. Some of them was very specific and it was industrialized. So the process was not a biological product, it was not a natural, it was an industrialized process coming from a carbon substance. And now with an industrial consistency, and this technology become really popular in places like California, where there was the backyard for this technology. Today I will discuss mainly about nutrition and about how this technology could benefit. So this reactive carbon technology had been produced in many primary nutrients, but mainly was focused originally in phosphorus. And why phosphorus? Because phosphorus is insoluble. I mean, phosphorus is probably the most difficult nutrient to reach the plant. And for those who know a little bit agronomy, phosphorus is energy. If you don't have phosphorus, the plant doesn't. The plant is pretty smart. The plant can read early on how much phosphorus the soil has. And based on that phosphorus, the plant reset the genetic code and it set the potential yield. So potato farmers are quite smart. They know that if the plant can perceive high level of phosphorus early on when the plant is young, the potential yield goes up. And it is the reason that we sometimes over-apply phosphorus with the hope that that phosphorus will reach the plant. Sadly, the biggest problem with phosphorus is the incapability of phosphorus to reach the plant because of it's in the wish list of nature. You know, everyone, micronutrient, microorganism, plants, the soil, minerals, everybody wants a piece of phosphorus, and it is really difficult to obtain phosphorus in normal conditions. So just give you an example. For example, sources, and I put an example here like MAP, DAP, and APP, and those are the analysis and the structure. This is based on P analysis, MP analysis. And the efficiency, you can see that typically phosphorus don't reach more than 20–25% in the best of the cases. And that is when you don't have any negative impact on the environment because of the solubility is so low, and the fact that phosphorus moves by diffusion is really difficult to reach the plant. But even under those conditions, when you apply 1-to-1, really low quantity of the original quantity applied will reach the crop. And that is a problem because of the plant requires large quantity of phosphorus early on. And not only early on, there are certain moments in the crop cycle that the crop will demand the availability of energy. If it doesn't have, the plant will reset with the amount of energy available. Next, please. So this is a really good example they have here. For example, you have a fertilizer, they have 100 units. And we know actually if that soil has just 1 or 2% of calcium carbonate, and that calcium carbonate can come from naturally because the soil has some calcium carbonate natural, typical in dry conditions, or if we're in acidic soil, we apply just agricultural lime. And that actually produced a huge reduction of that capacity of that soil to use phosphorus, because about 80% of the phosphorus now will immobilize. And that is that from those 100 units, now we are just ending it with 20 units. We already paid for 100, but only 20 will be available. Then we have something really interesting. Early in the season, we have low temperature in that soil, and that low level temperature, that 20 units now will have a hit again, but it's a 70% reduction. And this is literature. This is not me trying to make out those numbers. Those are typical numbers related to that. So for that 100 units we apply, now we have only 6 units that we are giving to the plant. So we have 94 units that we pay for that will never reach the plant. Or will reach the plant maybe later, but the plant is not demanding, or will not be the most optimal moment for the plant to have the best performance for that amount. Next, please. So can technology help us with phosphorus mobility? And the answer, we'll see if it's possible to do. So there's some factors actually that will affect mobility and availability, particularly in potato. So the initial soil level is critical because a soil that have low soil P levels, we know that it will have a response to just by the addition of P. But the addition of P is not a warranty that there will be availability when the crop it will demand. We know actually there are some conditions like pH, temperature, soil moisture. They're totally related with availability just because phosphorus moves by diffusion. And anything actually that slows down diffusion will have a lot to do with the mobility. The phosphorus tends to move really slow in the soil. That's the reason that anytime that we suspect that phosphorus has enemies for the movement, that phosphorus has to be applied the closest possible to the root system of the plant. Also, the presence of root exudates and the P fixation level in the system will have a primary impact, and also the mycorrhiza population. I have a little target I call validated effect, and those the validated effect is this technology that we'll be talking about. I would call it a structure P technology. Those blue target is research having validated that those effects on phosphorus availability have been proven. There are others that we may have an impact, but it's not really validated. The secondary is related with compaction, texture, organic matter, microbiology, and interaction with other nutrients. And it's another technology that also we produce. Most of the time we apply combined for the best performance. And once again, this technology acts in a different part of the system to ultimately look for affecting that poor phosphorus availability, particularly in potatoes, because potatoes is probably one of the highest demander of P, and with one of the worst root systems you can imagine to explore P in the soil. Next, please. So this was something really interesting. In the year 2000 and about 2009-10, there was a lot of noise in California because many growers, high specialty growers, potato, tomatoes, almonds, were actually switching from typical fertilization with polyphosphate with this technology. And the University of California, Davis, was kind of worried that the farmers were moving too fast without allowing the university to do the research. So the university decided to do a quick test and did actually involve a bunch of scientists to test in a soil that was in Central California. They have naturally conditions to retain phosphorus, and decided to do a really very, very practical, very nice test, which is comparing three forms of phosphorus, in this case phosphoric acid, which is one standard practice, ammonium polyphosphate, and a structure at 25 kilos per P, and then use a untreated control to see how much different it was from the system. This will be sort of the explanation how they did here. They performed this trial in these bare soils. There was no crop, and with this irrigation system, a drip irrigation system, whatever they did, they did something really nice. They actually, from the point of drip, they decided to map the exit of that P and look for a horizontal movement and the vertical movement of that phosphorus from that point. And every 2 centimeters, they will look for that. And they map it and horizontally and vertically in the soil, and trying to see if there was any difference between any of those sources. And it was true actually that during the 2 or 42 days, there was any movement. And here is the graphic, and in the green, you have a phosphoric acid. When they apply, and this is centimeter, when you see on the left from the right, distance from the point of application, 2 days after application, there was a surge in the availability, pretty much focused in the point of application, but there was no much diffusing from that moment. And 42 days, when they came back, the soil actually was kept moist. And when they come back to 40 days, what they observed was most of the P was gone. The soil was capable to retract that phosphorus again and immobilize, and that phosphorus was not any longer available for the soil. In the case of polyphosphate, was not as good as phosphoric acid the first 2 days. However, it was more available over 42 days, but pretty much focused to stay close to the point of application. But on the right, you can see a structure. A structure was applied, and just actually 2 days after application, it was an extension all over the horizontal, almost covering the entire region, and actually was going deeper, even whatever they were looking for at the depth at just 2 days. And that observation only was observed 2 days, but 42 days, what they observed is they kept adding water, but the P was keep moving, even in the concentration they had later applied and observed early on. This actually was the open door to understand that they were facing now a technology that it has certainly availability of P. This information is published in a journal and is available for anyone to read. There are so many years of trials across the US. This is data from 2004 through 2008. The consistency of the data is when there was the presence of this technology, particularly in potato, we always observe a consistent reduction of application of P with an increase of production on the crop. So we already have tested this technology, and we know that it's about 2 to 3 times more efficient in terms of providing P. And we always found that when we applied less P consistently, only 1 year we didn't see any yield differences, but the other was the only other 6 years that we're evaluating and replicated trials, we consistently observed an improvement on this. The next I will present some data. This data is from 2012, done by a consultant. In this case, actually, he was evaluating the impact of this technology against the standard practice that was using about 100 kilos of P per hectare. And we call optimize. The optimize was reducing only 1/3 of the P and applying this Black Ultra at 20 liters per hectare to see if that could produce an impact. And what you can observe is the set of the tubers. Let's return one, please. The set of the tubers actually was increased. We observed that the plant was capable to, which is telling me that early on, the plant was capable to increase potential by setting more tubers. This is, but that 5% tuber was not correlated with the yield. The yield actually went up. Now we can see the next slide. It wasn't a spoiler. It was 22%. So we're observing that even though we're setting up 5% more tubers, the total yield actually went up by 22%. And this is very consistent across what we see. We see is applying less P will provide you more potential yield. And we have no doubt that we're using much better the phosphorus into the system. Next one, please. So the question is, can we use technology to increase nutrient efficiency, particularly with phosphorus? And without any doubt, I would say yes. In this century, we're being called to look for technologies that can do more with less. And we totally believe it's possible. We do business on that. This is part of our business model. How can do better with less than what we have available, to less impact into the system. So as a summary, I would say that it's important to understand what do we have in the system, what nutrition levels we have, because at the end of the day, one nutrient is not responsible for the entire overall response. Nutrition is like humans, you know, you always will be bounded by this, what is bugging you the most. However, it's important to say the phosphorus is essential because it's energy. Anything actually requires energy will go for that booth before it will require anything else. Water and energy are the two most limiting factors for biologic systems to operate. Understand what type of soil you have and how can we use them better is essential. Use technologies backed by science and know by marketing strategies. And I think this is, I used to work for Arista Life Science as a global manager for biostimulants, and the Bill Gates Foundation, actually, I don't know if any of you had heard about this, about 7-8 years ago, did a research, and they'd actually filter 100 most known, well-known biostimulants because they were looking for an alternative system for Africa. So they were trying to see if these biostimulants were right or were wrong, or they were just a bunch of snake oils. What they found was something really interesting. This is something we have to pay attention. They found that from the 100 technology they tested, only 5 make their next line of the second year of trials. The other, there were 95, they have no effects whatsoever in whatever they were looking minimum for this. So it's telling us it's not they are not working, this technology doesn't work, is we have to be careful what to pay attention in what is backed up by science, what is not. So I would say that technology is the future. and we have to look for them and careful to choose what the one that will fit best to us. With that, I will pass it to Mr. Mick.
Thanks, David. Yeah, so guys, just in summarising here, it's really important, obviously, to evaluate new technologies on your own farms. You know, what works in one part of the country may not work in the other, and there's so much variability between paddocks, let alone different geographies. So are they going to work every time? You know, no nutritional product works every time, and I think we need to be very clear on that. But from a scientific point of view and the R&D point of view, that is very sound. The global track record on these products is really promising, and the ability to be able to bring these as business to Australia and put them in place on farm, let the products do the talking with you guys is really the exciting thing here. And you know, from a potato point of view, we're obviously heavily geared towards granular inputs. So utilising more efficient forms of technology that are liquid. You know, if we get some good runs on the board with trials over this next couple of seasons, then you know, it might require us to update some of our on-farm operational methods to be able to put in higher rates of liquid that we're dealing with at the moment. But before we get to that point, you know, commercial scale demos are taking place at the moment, potentially with some of you on the call. And to complement those, we're also collaborating with some external parties to generate independent replicated trial data that we can really fine tune some of these rates. So at the end of the day, it's important that we collectively measure the response when we're using any of these type of products, and unless it's measured, it really can't be managed. So with that, Doris, hopefully we haven't run too much over time. And but by all means, guys, if you've got any questions, I wasn't able to see any on the chat box just while I'm sharing my screen, but happy to take any. And by all means, if you want to look at any of these technologies, please contact any of our agronomists in the Nutrien Ag Solutions business. Thanks,
thanks, Mick, and thanks, David. You might want to unshare the screen again, Mick. And please, if you have any questions, wave your hand or type them in the chat box. Probably, to me, a couple of the main points are really to try in your own production system what works, because it's like with any other product, it's not always fail-safe, especially if you're talking about biological products. And I guess any question now? No questions at the moment. You must have been very convincing. So we hand over to Mike Radke, because he gives us a bit of a tips in that regard, monitor to manage, and how that might work. You ready, Mike?
Yeah. Is it up?
Yep, coming. Yep, here we are.
Okay. I guess I'm going to follow on. Yeah, I guess being me, there's going to be a little bit more of a pathology basis than a nutrient basis, but the reality is they're all intertwined.
Can you go into a different view, please?
Oh, that way. How's that?
Yeah, that's better.
That's improved. You can actually see something now. Right. So they're all intertwined, but yeah, being me, obviously, predictor, and being more on the pathology basis, there'll be a little bit more of that in this presentation. I think, you know, if we're looking at evaluating treatments, and whilst normally I'll come on here and talk about pre-plant risk assessment and that sort of stuff, the technology we have and the technology other people have, it's really critical background information during other trials. But whenever you start, like if you're looking at an issue, if you're looking at using a biological or any other change to your system, whether it be a nutrient solution, you really got to get to the bottom of what your issue is. And sometimes your issue is not necessarily what you think your issue is. Being pathology basis, I've put, you know, up there we got powdery scab, we got rhizoctonia, various, you know, acting on the crop at various stages. But when you look at it, you know, the powdery scab one, I guess, is easy. It's going to be Bispongosperm. But the rhizoctonia one, it could be any of 3 or 4 strains, most likely be going to be 1 or 2. In the case that the picture's there, it's AG 2.1. So A, you've got to make sure your diagnosis and your thing is correct. But then you got to dig deeper into it. What do you actually know about it? Before you go off on a tangent of what we're going to apply, you really need to be thinking about, you know, if it's AG 2.1, rotations are going to be important. If it was AG 3, you're probably looking at seed and previous potato cropping history. So, you know, that's going to inform where you go, how much you know about it. But the other one is what can you do about conditions? Because conditions are ultimately one of the biggest drivers of all sorts of problems in potato paddocks. Whether that be, and you've heard mentioned multiple times today, that where you know, salinity is a big part of it. Just water relations in general, whether it be waterlogging, too dry, variability across paddock, dealing with all those sort of things is absolutely critical. So you really need to look quite broadly when you're thinking about defining what your actual issue is before you start looking at products. Now, I guess I was specifically asked today, I suppose, to think a bit about biologicals, because there's more and more biologicals out there. A number of companies actually do get testing done for their trials through us, so we do see quite a bit of that. But there are a lot of biologicals, and I don't envy growers sitting there looking at the large list of them. But you've got to ask some basic questions up front. And I actually had to talk to Ross here because he's done a lot of work with Rhizobium over the years. Rhizobium is one of the most well-known and proven biologicals out there, and even it you need to know a lot about before you make it work properly. So what are the questions you're going to ask? Well, what actually is it? That's the first thing, right? Now, for some, there'll be very good information on it. For others, there won't be. If it is a biological, is it actually present and is it viable? They're really legitimate questions to ask right up front, because ultimately you still got to struggle in the field for colonisation, but you need to know that it's there and viable to start with, and whether you can actually get any good hard information to back that up. If so, how might it work? Like, where is it actually targeting? Is it going to try and colonise the plant before the others are there? So is it basically going to take up the space that the pathogen's going to take? Is it actually going to put out exudates? Is it going to actually, in some cases, consume the pathogen or whatever? You need to know that, because that's fundamental to how you're going to use it. And the next question is, has it actually worked anywhere else in the field? And that's important for 2 things. One is because we do a lot of laboratory trials here too. We try all sorts of enrichment sort of stuff on that to improve our own tests. And then we have to take them out in the field. That becomes the challenge goes up dramatically when you do that. But the other one is, if it's worked in the field, it also gives you clues to how you're going to apply it. Because unlike a registered chemical product, there's not necessarily all the information about how you're actually going to do it. Because there's obviously regulations around chemicals, and they've been proven in certain spheres to work. So that's where you apply them. As opposed to a biological, which can be a lot more complex in actually getting to the bottom of it. That leads into your next set of questions once you get over those hurdles. When is it needed to have an impact? So hopefully you've worked that out from above. How must it be applied to be effective? And how must it be supported to be effective? Now, obviously, if you put it into an environment, if it's biological and you put it into an environment that it can't cope with or it wasn't naturalised in, it's going to struggle to survive. The other thing is you're applying a lot of other treatments, and are they going to be, it's one thing to support it, but you can also actually be very negative on it and kill it, right? So you've got to look at what your other treatments are that are going around it, because it's coming into a system, and I guess all growers use systems, because that's how you build up your knowledge over time to produce good crops. And the last question is, how will you know if it worked? I guess I'll just put up a couple of slides here, and you might say, well, I will say that these slides aren't necessarily related, right? So the tubers aren't related to the crop that you're seeing beside it. They're 4 independent situations. But if you get an innovator crop like the one in the top left-hand corner, well, I guess you're going to be pretty happy for a start. Are you going to know whether what you did worked or not? Well, in this case, that was a virgin site. You're going to expect a good crop out of it, right? So was it challenged? And that becomes part of how you evaluate these things, and I'll talk about that in a minute. Then there's what other assessments can you do? I mean, obviously the potatoes below, you know that there are problems there, and that would have been a good challenge crop. It was a fairly challenging pivot that they were grown in. The crop at the top, the one that looks quite nice, what I can tell you about that is if you were to use NDVI or something like that across that crop, you're not going to see a lot of stress, not going to see a lot of things going on. That crop had a very high level of common scab on the harvested tubers. It's not really going to show up in the top. So it's all about looking at the right things at the right time. If you were digging up early on the crop, you'd have seen that starting to emerge. The bottom one is, you've got black dot verticillium going on there, but you've also got quite a change in soil conditions and obviously associated moisture conditions as you go into that particular patch that's badly affected. If you set a trial across that, you need your strips to go right through those areas, because if they were going the other way, it's not really a fair comparison. That's when you're doing on-farm trials where you may not have the same levels of replication that you would as in an experimental trial that a researcher might conduct. You need to have strategies to make sure you get decent results. So I guess I'm just going to go through, and I'm trying to overload you, but I guess I'm just trying to give you a whole heap of things to think about when you're trying to evaluate a new treatment in your system. So if we're comparing a new treatment, first thing is you need to select the site and confirm that it's risk and suitable. Like, for instance, that previous crop that was in the virgin site, it's not going to challenge too many things. It's going to be a good crop unless you make some mistakes. But in terms of, you need to do, if it's pathogens, you need to look for those pathogens. You either need to confirm with our type of testing or past history. If it's nutritional things, you need to have your soil tests against it to know, and past history of actually what you're going to do there. The next one is, whilst you want these challenges, if you're looking at a trial, you either have to minimise the variability across that trial site, or you need to evaluate in the different sections of that paddy. Because if you don't get rid of that variability when you're comparing treatments, it's actually going to, in most cases, overweigh what you're looking at, unless the yield differences are massive. If the yield differences are much finer, you have to manage that variability in your strips or whatever you put through. So that's all about having controls and having a decent control that's a fair comparison. And if, as is the case in an on-farm trial, you're more likely to be often using strips through a paddy, you can still replicate those strips. You don't just need one here and one there. You can actually separate those out, right? Sometimes that can be a little bit more difficult to do, but if you've got a control on both sides of a treatment, it's going to be more informing than just a single control versus a single treatment beside it. So the other one is, when you apply some of these things, obviously within your system, sometimes you are going to have to change things. If you've got a control treatment coming in, you are going to have to change some other things because they go hand in hand. They are part of a system. So if you're putting a product in that requires a system, obviously you're going to change those things. But if you're not doing that, the more things that you change in that system when you do that comparison, the more difficult it is for you to assess what those results are in an on-farm trial. So the second side of that, and it plays on what I just said there, it's only things that you have to bring in to support that product or that system that you're going to change. Otherwise, you really need your controls and your treated areas to be treated as much the same as you can. Then you move into the observing and taking notes. You might say, it's always taking notes, even for researchers, taking notes can be laborious, but sometimes it's those little notes of something you see early on that will actually explain something that happens later on in your trial, and it often can help understand why a particular product hasn't performed the way that you might have expected, because they're not going to perform the same every time in every trial. We all know that, because they're very different. Now, the next one is about taking quantitative measurements. Now, I guess that's always getting easier because gradually people are having more and more technology in their field, GPS monitoring, all that sort of stuff. It is actually getting easier to get large-scale, good quantitative measurements of the effects between two different things. But you may also want to be taking quantitative measurements on things in the field, like that common scab example of that crop there. Now, if you're measuring all top growth stuff and NDVI and all that sort of stuff with drones and whatever, you're not really going to get to the bottom of what was going on in that crop. So you need to be taking the right type of quantitative measurements, because those measurements are really going into assessing what are the underlying reasons for the effect. Sometimes when you apply a biological, they can have a lot of different ways in which they can work, and you may not actually realise, you know, unless you're looking at what the underlying reasons are for this, you're not going to be approved on it in the next, like in the use of this biological. You really need to be building your information over time. So you need to be building your understanding of how that's actually working. And to do that, you're often going to use technologies to assist. Now, because I guess we do predictor testing, and I will go back to the pathology sides of things. If you're going to do trials where you're looking at soil-borne diseases, there are a few things that can bring you undone. One is that you don't get the environmental conditions for that disease to express. And that's often what happens in trials. You can lay out a whole heap of trials, you don't get the environmental conditions, so you don't get the disease expressing. There's not a lot you can always do about that, but what you can do about is know that the pathogen's there in the first place, right? There's no point setting up a trial in an area that's not going to challenge it. So you really need to be looking at, you know, making sure from your past history, but also looking at, you know, predictor testing to actually quantify both in the soil and on the seed potatoes, because both are very important. And often you'll see people look at one thing and they'll get it and they'll be basing it all on what they think the paddock's risk is, and then they'll plant seed that brings another risk in that very much complicates the whole trial and the results that you're going to get. So you really need to think about both of those inoculum sources in a pathogen trial. But the thinking's no different if you're doing other types of trials like nutrition. You really need to understand what you're working with in the first instance and work from there. Now, what I will say is that you're not going to necessarily assess things all of the time. The end result is always going to be about the yield that you get, the quality of that, the productivity. They're the end results that you're really after. The rest of it is all about understanding why you're getting to those points and understanding how you can do it better for the next crop. So if you're looking at the pathogen side of things, we have a lot of opportunities now. I mean, we always thought of it as a pre-plant soil test, but at the end of the day, we can go in and we can look at young crops. You can see the root system at the bottom there near the seed tuber. That's got a lot of Pratylincus penetrans in it. We can actually quantify that. You can know exactly where that's going and how it's building during the crop. So verticillium wilt, it's a very underestimated disease in a lot of production areas in Australia. So when do you go in to do that? Well, you go in to do it in about the middle picture there. That's about the best time, because that's when you're going to know that you've got infection. You could go in a little bit earlier than that. Now, you can do that visually by looking for vascular staining, but that is by no means a surefire way of doing it. If you're to test those stems, you're going to get a good read on how much verticillium you've got in there. So, okay, it might be a little bit expensive to do that, but you're probably going to do it on a research scale. It's going to be a lot cheaper because you're going to be just looking at a single target or a couple of targets. So, and you can measure that right through. And ultimately, you're going to be looking at yield. Now, what I will say is, if you get the environmental conditions right in a pathogen trial and you see that, you're really going to rely on what your yield and productivity and disease incidence is. But if the environmental conditions aren't quite right, you can actually use DNA testing or those types of technologies or other pathogen testing to actually look into it and see what actually went on, even without a really crystal clear result, because they will still show up in pill testing or end of harvest testing for soils and that. So, and then you can go forward right into that and you can see that all these things carry over, and you've got control of volunteers into a cereal crop after that in the rotation. So you can manage that right through until the next crop. But ultimately, it's all about thinking about things up front and actually making sure that you're taking the types of measurements that are going to give you the results you need to understand the system better. Now, I'm going to leave a little bit of time if there are some questions, but in terms of all of that, there are a few important things to think about. It worked, great, but one success does not make a solution. And I think we've heard a bit of that today about, you know, trial after trial after trial that builds knowledge. And that's a very important thing to do. And it really takes time and multiple, I guess, on-farm trials to do that. You don't want to get overly confident with your first success, but the more underlying information that you've measured to get to that result, the more confident you can be in that result. Likewise, particularly if you're working with things like biologicals in the system, it's complex. It is complex, the application of biologicals. As I said, I talked about the rhizobium with Ross, and this is a system that's been around for a long time. And in their system, if you know a lot about the system you're applying rhizobium in, you're probably about an 80% chance of getting a reasonable result in a system where you're going to get a result. But if you don't know, he said you're probably about a 20% chance of actually getting a result, even with a product that's been around that long. So you don't, when you're using these more, I guess, complex systems, you do need to understand a lot about them. And likewise, one failure does not mean it cannot be made to work. If you had really good reasons for why there's a failure and you saw that you just can't get it, well, that's fine. But ultimately, a little bit of persistence is needed for some of these products. But you don't want to go on forever trying to make something work that you can't. But giving up on the first attempt is probably not the way to go for some of these more complex products. I'll leave it at that. I've sort of scooted through that quite quickly, but if anyone ever wants to talk to me about any of these sort of things and I guess ways to go about actually shoring up trials, on-farm trials particularly, that's great because, you know, ultimately, even on-farm trials, you can waste a lot of money if you don't get some of these basic fundamentals right. You really want to give yourself the best chance to get them right.